questions afterward. I'm just going to say that you'll answer them. All right, anyway, please give a round of applause. Thank you, everyone.
Test? Ooh, that's loud.
I'm closing that down in a minute.
Oh, is that how you do that? I wonder what that was. I thought it was my slides. Does this work? Okay, good. Hey, I don't normally use a microphone, so if I'm too loud, let me know. I'll turn it down, maybe. I'm Matthew White. I teach at Penn State, and I work at PlayStation. So I can tell you a little bit about what I do today. This is actually kind of a retrofit of a presentation I gave at a data analytics summit in San Francisco about 4 weeks ago. So forgive me if this seems a little off topic. I'm going to kind of ad-lib it to meet your needs. And please, that the whole idea about this is Dr. Voytek asked me to kind of give you an idea about what we do, and that's sort of the overview here. So hopefully what this means is you'll be able to apply some of the stuff that I'm sure he's been teaching you to kind of the work I do. I'm going to give you an upfront warning, though, that like most things transitioning from university to the real world, everything we do is much less accurate and much more slapdash than what you're being taught. And that's honestly almost on purpose. I would hope that's the case with all disciplines except maybe like medicine or engineering. But other than that, it's some kind of tumor. Anyway, who am I? Okay, I guess I kind of did that already. Grew up in Canada, taught at Penn State for 6 years, worked at Volition on the Saints Row games. Now I work at PlayStation on about 1 million games in a central group. Okay, we're going to talk a little bit about how video games do telemetry and data, what our pipeline looks like, and where that fits into the entire game development spectrum. And then I'll give you little tidbits of our data throughout and kind of the places where we're facing trouble. This talk was actually not meant for games industry people, so it's extremely high level. So if you know anything about the games industry already, it may be extremely redundant. And if that's the case, well, too bad. So yeah, that's me. I do have a doctorate. You can call me Dr. White. You can call me Matthew. You can call me Matt. I don't care. I studied ed tech, actually, at Memorial University, which is in Newfoundland, which is an island off the northeast coast of Canada. If you don't know, if you folded the entirety of North America along a diagonal, San Diego would land on it. So I'm as far away from here as you possibly can be without being in Europe. Been in the games industry about 10 years. And as far as my colleagues are concerned, I'm okay to tolerate. Let me talk about, oh, that wasn't me. I blame you. Let me talk a little bit briefly about how we get our data. So we support at PlayStation hundreds of titles, everything that you've kind of heard of and a million things you haven't. Horizon Zero Dawn and Call of Duty and all of these kind of big titles, but also little indie ones like Stardew Valley and these other kinds of things. So game mechanics like shoot, jump, play, run, whatever, all exist inside of a game client. So that's stuff like shooting someone in Call of Duty, picking something up in Grand Theft Auto, choosing a story choice in Mass Effect. These all issue like events. So it's an event-driven system. And all of that is emitted through a Kafka-based system to a storage system that we have, which runs on S3. So primarily, we do that for two reasons. One is to kind of research what our players are doing and get a better picture of what sort of the ecosystem of our players look like. And that's kind of a psychological side. The other is to drive monetization efforts. We want to know kind of what people are doing that prompts them to spend money in a Bayesian sense. Like these 3 or 4 events happen, and then there's a conversion to a paying customer. That's kind of the business side, the sort of like dark Sith side of what I do. And then the other side that I really do enjoy more, and unfortunately is less of my job than I thought it would be, is spending time really kind of looking for clustering, things like that around the kind of behaviors that people engage in, especially in like open world and open-ended games. That's always been kind of my interest, is how people engage with open systems. So this is kind of our basic data pipeline, and this is kind of software-y. Did you give them a software talk already? They kind of know something. Oh, shit. OK, so this is completely off the wall. OK, so consider this your intro to data engineering. Don't claim it on your course credit. So all of our clients are here. And by clients, I mean both senses of the word. That's like clients like people and clients like entities, like running applications. And they emit stuff in 2 directions. So every time you die in a video game or pick something up or whatever the programmers have elected is important to the designers. Nice shirt back there, man. Anyway, sorry. It gets doubly emitted, one side to the PlayStation Network and one side to our ETL. The PlayStation Network, you know, it's where you sign in, trophies, that kind of thing. It's all tracked there. I'm getting cold call data sales calls all the time after the last one of these I did. So if you sell my information, I will find you. Literally right now. You know Periscope? Those people call me nonstop. Anyway, sorry. ETL. Everyone familiar with that phrase? No? 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 Cool. Extract, transform, load. So I'm sure one of the things you've been introduced to is the concept that data that comes in is not pretty a lot of the time, right? Like you're looking at disparate sources of information that have widely divergent formatting. They could be in a million different data formats. They could have completely different payloads. That's kind of what happens in games, right? Because every video game that we support has a very different kind of, first of all, software backend. You know, some of them are built in a particular programming language using a particular engine or a particular framework, that kind of thing. And no two of them might be alike. As you can imagine, games like Call of Duty are built in a very different kind of system than like little mobile games that we also support, right? Like very different engines. And so the type of data they emit is non-standard. Generally, it takes the form of kind of a JSON-ish text stream. So you can assume that most data coming in is in some kind of unformatted text. What the ETL does, it's a piece of software written in with mostly Apache open source stuff. I'm trying to figure out what I can actually tell you and what will get me fired. Yeah, it's primarily built on an open source backend using Spark streaming, which is a really popular streaming solution, and Apache Kafka, which is a many-to-one message aggregating system. So when data comes through from a Call of Duty or from a Stardew Valley or from a whatever, it gets sorted in this sucker into a usable format for us. And what this means is someone logs in here, some human sitting somewhere, and sits with a designer and with some Python writes out like, okay, what do you want these endpoints, like tables, to actually look like when they make it to Redshift, which is what we use for our storage and analysis. And you know, this literally looks like just building SQL tables. So this is something that should be familiar to, honestly, everybody. I mean, you know, it's relational database management, customer, height, weight, age, that kind of thing. But what we're collecting is not data about people usually, but data about behaviors, which are then associated back to people. So it'll be like, if this is a death, what weapon killed them, what were they carrying, what time did it occur, where did it occur on a map, that kind of thing. And we store that data on SQL for various types of analyses. It also gets double Dutched over to S3, which is kind of a cloud-based storage system from Amazon. It's slow as balls, but it is cheap and big. So what this means is if you have a whole bunch of stuff that's not necessarily necessary to analyze at a granular level, you can store it here for kind of slow boat access later on. Selling people on the concept of statistical sampling, as an aside, is really difficult. People seem to believe, like we have an audio department. I'm going to probably get fired for saying this. Everything I just said you didn't hear. We have a department at a place nah, this is fine. Yeah. Buy an Xbox. Yeah. Anyway, yeah. So anyway, we have a department at work, and they're great guys. Don't get me wrong, very talented. But not their job to understand. And this actually is kind of relevant to your work if you end up doing this. Not necessarily their job to understand like complex statistical rigor. You know, I mean, these are musicians, right? Like they're talented. Like, I mean, if you've listened to God of War, Horizon, amazing music, but they know literally nothing about complex mathematics. So when you try to sell them on the concept that like, okay, we have 22 million players, we're going to pull out like 1,000, and I'm going to use that to tell you about all 22 million of them. They don't buy that at all. Like the fact that that happens is completely false in their minds. So they will force us to pull out all 22 million to be satisfied about things. And this means queries are expensive and slow. So some of this is being a diplomat. You will get there. Anyway, then once that's pulled out, we analyze it in various ways. We use Tableau for visualizations most of the time. Minitab is kind of my statistical baby, but I mean, you can use whatever the hell you want. Python's big, R is big. You probably know this. Okay, so as I was saying a minute ago, I have a bad habit of never actually switching the slide. Excuse me. All of the actions we do in a game create data, and it's in completely different formats, and I really want to impress that on you that like while you might think that like 80% of my job is walking into a room full of game designers with a big hefty report and being like, here's all the cool things I found out and how they're going to be impacting the games you're making. 80% of my job is figuring out how to reconcile, I just blew a guy up and I just made a 16-year-old chick ask for eggs and bacon for breakfast. Because those actions produce totally, totally different kinds of outcomes, right? Like Life is Strange over here, which is a wonderful game that you should play, is kind of a choose-your-own-adventure dictionary type game, right? So what we're tracking is a path. Like players went to, if you think about like the old choose-your-own-adventure flip books, which even I'm honestly too young to remember, but I know of in passing. You flip to page 20, flip to page 80, and that path is what we want to trace. So for visualization purposes, what we want to deliver to the designer is like a heat-mapped path of this is the path most people took. And that has knowable, palpable business outcomes, right? Like things like, oh, well, if 80% of people didn't see this particular path over here, why did we spend all that money on it, right? Like there's clear implications there. How do we encourage people to take more divergent paths, that sort of thing. On the flip side, knowing when and where people blew shit up is a totally different kind of thing that also has implications. We do three-dimensional heat mapping to let people know, for example, where people are having problems in levels or where there's like too many deaths happening or there's a physical bottleneck, sort of improve usability for our customers. We use it before launch and after launch, kind of these data tools that we have. The pre-launch is up here now, and we use it primarily for what I've been talking about, which is like design iteration. So what I mean by that is we will have what's often called in the games industry like a soft launch. So what this is we make like a beta version of a game, put it out to 10,000 people, gather an ass butt of data from those 10,000 people, pull it back in, do some crunching, and then bring those data insights back to the design team who then iterate on the process and we repeat that. And that's usually kind of what we're doing at any given time. The other half of the job is kind of post-launch, which I'll talk about in a minute. We also have a user research team at every one of the Sony properties. And there's dozens and dozens of them worldwide. So what those people do is in a very much more qualitative, small slice sense, sit with a smaller group of users to get more kind of deep dive insights into the kinds of things they're doing with sort of traditional qualitative and social science research protocols. We use some biometrics. We use Think Aloud protocol, things like that, to try to get an idea into what they're doing and why they're doing it. We also use it for bug detection. So this is kind of anomaly detection is really important. So you can use a very basic, and I mean very basic, machine learning algorithm, and it's really not, it's like just a rolling average, to keep an idea about counts of a particular event per user over time and create a very simple Python bot that notes when a user deviates way outside of that, and just simple outlier detection and then sends off an alert. And that's something we do a lot of. And the idea for that, of course, is to try to obviate exploits and hacks and cheats and to make sure all of our players have kind of an equal playing field. We also use it for game balancing. Anybody play competitive games? League of Legends, Hearthstone, stuff like that? Like 4 of you. Oh, okay, fine. Anyway, so to give you a more salient analogy, if you had like these 9 people play hockey against like the Pittsburgh Penguins, that's not what you would call balance, right? So like one is clearly trained and one is kind of people off the street. Yeah, I mean, he could be a great defenseman. He's tall. Anyway, so the reason I bring this up is this is really important in competitive games, right? If League of Legends, for example, it's a game that's only competitive, there's no real single-player mode, it's always against other people, Overwatch, Hearthstone, things like that. If we don't have decent balance in those games, it's a really bad experience for people, right? You don't want to jump into a paintball kind of game with someone who's using a shotgun, like an actual shotgun, because you don't have really a good kind of experience there, right? And that's not fun for our players. So we do game balancing by looking at sort of kill-death ratios, skill ratios, and making sure our matches are really tight. That constitutes a pretty big portion of my work as well. And we assist QA in kind of hunting things like frame rate and stuff like that. Here's an example of mission analysis from a popular sports title, MLB The Show. It's a baseball game for PlayStation. These are just basic charts. These give you different ideas of, I blacked out a lot of data on here so I wouldn't get fired. So I just got to figure out real quick what these are. Oh, OK. So on the top left is a distribution of completion of our missions based on the number of players by day given a particular time. So what this tells you is like popularity, and relative ease of missions over time. And down below, we separate them out by a particular category. You can see that these two are much, much, much more popular than these. And on the right, we do the same with progress. So what this is how many people are actually completing versus how many they're leaving sit in their, like we started it, but we didn't finish it. So this combination of things lets people know, are we getting the most bang for our buck in terms of spending design hours in our team versus players actually having a positive experience with it? How many people are actually finishing things versus starting them? As a series of kind of community and playership-based insights that we can glean from this kind of thing. Here's a free-to-play game that came out lately, Drawn to Death. This is a pacing example, what I was just talking about, where we want to know how long it takes a player and where they get stuck at particular points during a tutorial mission. So tutorial, if you don't play video games, is kind of like at the beginning we teach you how to play, and it's usually like somewhat mandatory, like soft mandatory, to go through that to kind of get your bearings. Again, it'd be like, I grew up in Canada, so it'd be like if I took you curling and you had no idea what the fuck curling was. I would probably give you like an hour of like, this is a broom, and so you get the idea. And that's what this is. So what's clear here is, this is just sum of time across the different portions of the tutorial. You can see that there's like sticks right here and right here, right? Like these are harder for people. They're getting hung up in these areas because the plan by the designers is that each step should be equivalent, right? So after the fact, we can take this data and be like, hey, you have a problem on this particular bit here. So let's go take a look at it and see why that's stopping people. And we deliver that back, and that comes out in a patch. To be real, we really rely on the internet, right? Like live patching and being able to fix stuff after there's problems. There was a time not that long ago where the kind of stuff that I do for work wasn't even possible, right? Because once the game was out, it was just out. And unless I was going to like mail you another disc or something. Actually, pause for an anecdote. Hey, you know Legend of Zelda? Yeah, okay, good. Right. I mean, you'd have to be living under a rock. But so that came out in like the 80s, right, when I was like pretty little. But Zelda 2, which was this really bad one, came out for the NES in like 1990. And my cartridge was fucked up badly because they released a batch that wouldn't let you finish the game. And so they had this whole mail-in program they had to do where you had to like postage-paid mail back cartridges. And this is something that's completely been revolutionized right now. It's like, oh, we just stick a patch out and we're kind of done. I think I street passed you on the way in, guy with the DS. I noticed that in my, just saying, I did. Yeah, anyway. So let me move this on. So we also have a post-launch portion, and this is after the game actually comes out. We do a little more work, like I just said, to make sure that that cartridge situation doesn't happen. We really don't want to release a game that's broken, right? Like when The Sims came out in 2010, like it tanked EA stock because they spat it out in a bad state. And that's not intentional, by the way. There's realities of production that make that, like this happens mostly because people literally run out of time. But we don't want that to happen. So post-launch, we do data analysis to make sure that there's not stuff out there that we can't see. There's also an interesting phenomenon that happens where assholes are a lot louder than normal people. So if you just go on the internet and you like Google MLB The Show, 80% of your results will be like, fuck this game, and things like that, because those people talk a lot more about how bad things are than the actual majority of our customers. There's what we call like a bimodal distribution, right? Like you have people that are really, really happy about it that tend to share videos and tweet, and they really love it. And then people that really like think it absolutely is going to bring about the apocalypse and hate it. And so those are the only people we ever hear from. But the reality is the vast majority of our customers exist on that middle continuum. Exist on that middle continuum somewhere. So we want to make sure that those people are being well served, and the data analysis that we do in the game balancing is critical to make sure that we don't, as designers, like people that are artists, I mean, they love these games, they make them, they play them, but their knee-jerk is to respond to their fans, because they see themselves as like servants of society, right? Like when my fans are upset, I have to make a fix immediately. But unfortunately, it's kind of like if you have 10 kids and one of them says it's too warm, and then you freeze the other 9. So the trick is the quiet ones need to be heard as well, and that's unfortunately the most of our customers. So that's where data helps us out. This is again with game balancing and bug and exploit detection, but what becomes important after launch is what we call feature analysis. So if you make a game and you're like, okay, the game's going to have this customization system and like this online multiplayer and this other thing. Each one of those costs like real world millions of dollars, right? So if we put in multiplayer and 4% of our clients ever use it, we done goofed, right? So we have to make certain that we're actually getting a return on investment. And a lot of things, unfortunately, and this is going to be the real world for a lot of people, we're often asked to kind of give a dollar figure to how much that actually made us by putting it in. And sometimes, sometimes I'm sure your statistics professor has told you that stats is like math plus magic. Well, trying to take that and then turn it into a dollar figure is like math plus magic plus bald-faced lies. And that's what we do on a regular basis. The other portion, the other thing is popularity, ranking, and usage, and this is mostly vanity stuff. You engage with the community, and it's like, hey, did you know there are 40 million hours of blah, blah, blah played this weekend? We do stuff like that to engage back with our community. And we also do a thing called concurrency. Multiplayer games and games that are online require a server, right? And like knowing how many people are going to hit that server at a given time has a real world value, because if you're paying for server overhead you don't need, you're wasting money. Contrarily, if you pay for not enough and you get hit, you have very angry fans. So trying to predict in a meaningful way, just using basic kind of machine learning and prediction algorithms, how many people are going to show up on a server at a given time is actually really important and a big part of our post-launch work. That matchmaking analysis I talked about before, here's Drawn to Death, which is, again, it's kind of like a multiplayer competitive thing. You shoot out deathmatch kind of deal. So what you have on top is just a histogram of MMR is matchmaking rating. It's just you ever play chess? ELO. It's that kind of thing. It's a thing. It's a single number that kind of tries to encapsulate how skillful you are. So this is a distribution of all of our players, where they fall on that, and it looks somewhat normally distributed. The reason you see this bulge right here is because the default value is 1550. So if they haven't ever played a match, they end up with 1550. But other than that, you see a normal distribution. And the bottom is Matchmaker Effectiveness. So what that is a distribution of every match that's ever happened, the maximum ELO in the match, or MMR, minus the minimum plotted. So the idea is that the more right-skewed that is, the better we're doing. Because obviously you don't want someone who's like 2,000 paired with someone who's like 1,000, because that's that whole shotgun paintball analogy, right? So we actively try to get rid of these people. And so this is a report we deliver daily to the people who balance this game, and they make tweaks, tinker the matchmaker to try to accomplish that goal. Playtime analysis, Starblood Arena, another game. This is a VR headset type game. This gives us an idea of how playtime is changing over time. Obviously, going up indicates that people are engaging with the title more and kind of having an enjoyable experience. That's positive. Distribution down here, just sort of a standard box and whisker. So we also do this alphabet soup garbage. I'm really not a fan of this, and that I'm fine with that being public and on record. This is because there are executives who, in their infinite wisdom, want to know all of these kind of vanity metrics. And so these are things that take a million complex things and cram it all together into one sort of number that they can look at and say, that went up, that went down, and then they get a pat on the head and whatever. So we provide that to them on a regular basis. These are things like ARPU, which is average revenue per paying user, and these go on. My distaste for these is well known at the office. I have a little pug with picture in my, so there's one called ARPMAL. So it's average revenue per paying monthly average user. So what that is take the revenue for the month, the number of users per the month, suss out the number of users that didn't pay any money, take the average of that, and then divide it so that it's amortized over a month. And then tell that to an executive so he can smoke a cigar. But so I thought it sounded a bit like a communist dog barking, because I'm a fan of bad jokes, ARPMAL. So anyway, there's a little pug in my kiosk with a little like Cossack hat. That's my ARPMAL. So anyway, we do that, and it's stupid, and I hate it. But we do it all the time, and it's great. We also forecast growth markets. This I actually do like. We look at geographic distribution of our players, where they're changing year over year, to try to predict where we need to do more advertising campaigns, where we need to deliver more resources, build new PlayStation Network servers. China, India, Brazil, like exploding right now. And so we're very actively watching those kinds of markets to see that we're kind of meeting our needs in terms of making sure players don't wait forever to get on the PlayStation Network, have a bad experience with regard to queuing, waiting for matches, that kind of thing. We also track piracy like this. We can know pretty easily when you connect to the internet whether you bought that game or not. Duh. And so a lot of the time it's funny, different game developers, we leave it to our developers unless it's a first-party title. Most publishers leave it to their developers to kind of be like, this is how you want to deal with piracy, whatever. But obviously we don't like it, we don't want it happening. So we can figure out where people are pirating our games to some extent and try to take steps to correct it. We also research engagement to promote conversion, and that's that whole idea is certain titles there's like kind of two models of how you make money with games, right? Like you make a game and you sell it and people like it and it's great. This is the burger analogy. I cooked you a burger, you gave me $5. This is California. You gave me $13, and you enjoyed your burger, and that's that. The other model is I gave you the burger for free, but I charged you $1 for the ketchup, and $1 for the bun, and $1 for the lettuce, and $1 for the... And there's a lot of games like that as well. So as long as you're okay with an Atkins burger, that's free. But if you want anything on it, it costs you money. And that's kind of the sort of free-to-play freemium. You've seen this. And we track those players to make inferences about what convinces people to buy, and then, sift, twiddle our fingers and try to pull levers to make that happen more frequently. We also do A/B testing, of course. We might release something to one group, something to another group, and compare whatever you might imagine, conversion rate, balance between those groups to try to verify kind of designer assumptions, of which there are many. Here's monetization overviews with all of the numbers removed for MLB The Show, just to give you an idea of kind of what I'm showing people. It's like here's revenue per day as it's changed over time. Here's daily average users, which is concurrency, how many people are on the server. Down here is a rank of what modes people are playing. Over here, a rank of what people are spending money on. And again, everything is completely removed because this is private stuff. But that gives you an idea of the kind of stuff that we're delivering to the executive speak folks on a daily basis. Here's in-game currency payout. So there's two kinds of currency, right? Like we balance economies in the game. Like what a item costs in a game at a given time needs to be balanced. So this particular item lets us know how quickly people are earning experience in Drawn to Death, so that we can kind of tinker that to give people the desired time of experience that we want them to have. So, excuse me. We also, as I said before, engage the community with data. So this is like, hey, if everybody do the Pokemon Go thing, where it's like, not Pokemon Go, Pokemon Sun and Moon, where it's like everybody hatch this many of this type of Pokemon and everybody gets a reward. It's like a community thing. Like if you all work together and do this thing, a certain number, we reward everybody. And that's like an engagement promoting thing. So we do stuff like that and we provide the data to make sure that that's accurate and we reward the appropriate people. It's developing tracking systems. We also hunt cheaters and hackers. Over here is like, this is an anomaly detection of like stubs earned per day and like outliers. And we basically look for these people. But anyway, yeah. So that's again, redacted severely. Oh, and another thing we do is try to find insights about our users. So this is fun stuff. I like doing this stuff, but it doesn't have a really obvious business outcome, so I don't get to do it often. But what this is we look at, especially in open world and free-form games, we look to try to isolate different kinds of players. So this is like people that choose to do this kind of behavior, or you get the idea. And we use things like k-means clustering, and a few other types of clustering algorithms to try to identify kind of segments of users, and then partner up with our user research team to bring those people in and be like, is this really what you do? And kind of validate our expectations about that. I've always gotten a kick out of k-means clustering because like you have to supply the means to it, right? So it's kind of like you're straight guessing when you start this stuff up. Anyway, here's item popularity over time to give you an idea for a free-to-play title called Guns Up. So this tells you that we broke something. It's like, oh shit, why did everybody buy that all of a sudden on the 15th? Fuck. And then the 25th here is a natural bump, because that's, Christmas. So people have free time and free money. Then there's exploratory data analysis, which is just literally this. If anyone tells you anything different, total lies. Sorry, unless he tells you differently, in which case believe him. But so EDA is like, we put unsupervised learning algorithms to run and just kind of see what they come up with. Occasionally, this means literally just doing something as simple as like a correlation matrix and being like, oh, hey, how about that? The people who watch more Netflix play more of this. I wonder what that means. And then we spend some time to kind of dig into that data. But this does take up probably a day a week. We just spend kind of thumbing through data and finding interesting insights and kind of chasing down those kinds of leads to see if we come up with anything interesting about it. You know, nothing world-breaking comes out of this, but we do find most often like usability problems. Like, why is it that people who use the video app use this game more? Oh, the name is super similar and the icon is almost identical. Oh, we got to go back and fix that because like they're hitting the wrong thing. So we find weird stuff, but it's fun. So here's our kind of our current challenges, and you probably can ignore this last part since the last time I talked about this was at a conference for service providers. So, but if you do have a solution to some of these problems, great. We have data volume problems, right? So when I was working on the Saints Row games, they're a game like Grand Theft Auto, right? Like you shoot people, only with more craziness. Like, man, you come to the video games industry. My first job at Volition, there is literally a 6-foot-long metal dildo over the wall when you come in. It's from one of the games. You beat people to death with it. It's great. Anyway, so we track the use of things like that because we're crazy people. But actually, it's kind of rubber more than it is metal. Anyway, I'm sorry. So the reason I bring this up, when you're playing those games, right, like you're doing a lot of shooting, right? Every bullet that came out of a gun in Saints Row 4 sent an event. So like one player of our millions could easily spit out 1 million events, easily, in a session, right? So what ends up happening is 22 million players, a couple million events apiece. This gets stupid and big and crazy. So we have to come up with innovative ways to sample it, innovative ways to actually manipulate it, because the data becomes literally unwieldy, because it's a simple volume problem. And we've had several interesting solutions to that. We've used Kafka to kind of obviate some of those issues by using it as a time sampler, where we create an empty server, literally stick a dipper into the data stream, wait 10 minutes, yank it off, and then analyze only this data as kind of a vertical slice of time. That's kind of one solution, right? But there's a million ways to come at this, and it's a bit like making bread without a recipe. Like, sometimes it comes out and it's just like, well, this is shit, and then other times it works really well. But you have no idea why in either case. Another challenge we have is developer buy-in, and I talked about that kind of at the beginning, right? Like sometimes it's really hard to sell people on the idea that you're going to somehow glean insights out of what to them just looks like a wall of numbers. Also, developers do tend to kind of be divas, right? Like they have a real idea of like, well, my game's going to be like this. And if you tell them otherwise, sometimes they just straight don't believe you. So sometimes when they create a spectacular system that they're really passionate about, it can be very hard to tell them, like, people hate the shit out of that, and not lose your job or get them upset, right? And sometimes these are big name people, right? Like Hideo Kojima is like on our payroll, right? And you don't want to come to him and be like, this sucks, because it's not going to work out well for you or your life. So you have to figure out good ways to like tell Spielberg not to do that, or to tell Michael Bay not to put explosions in things. Like that's a big challenge we face. Another one is our new technologies. We're currently working with the VR headsets, right? Like that's a big one for us right now. And that VR headset has really meaningful, problematic technical things that we have to hit. We need a really high frame rate per eye, right? Like 90 frames or better, otherwise people barf. And like, that's no fun, right? Like we don't want to get sick playing games. So 90 frames an eye plus 60 frames on the TV, right, means 240 frames a second in HD. And if any of you play games or watch TV, you know that that's really hard to hit. So consequently, the technical limitations there are of bandwidth and processor cycles, right? If I want to emit a whole bunch of events, I can bring that frame rate down. Bring the frame rate down, participant pukes on my desk. Not something we want to happen. So yet another one that we have kind of issues where we sometimes stage our data. So it gets just written to like RAM, and then in like chunks during loading screens gets quietly fired off. But anyway, there's a number of ways to kind of get around that, and yeah, current challenge. Yeah, I just talked about that, and that, and that. Great. Hey, that's me. Thanks. That only took me 40 minutes. Nice.
We have about 10 minutes for questions. What's the alternative to Markdown? Because I've had to do it right now a lot too.
There isn't one. Just be crushed under the boot of big business. That's basically it. I don't.
You don't ever try and teach your
Do I have an answer for this that isn't just me being a bitter asshole? Not really. We have stakeholders. We're an extremely big business, right? Like, I mean, PlayStation's huge to a stupid degree. Talking tens of thousands of employees worldwide, dozens of offices. So to some degree, you know, and go to your philosophy class for this, but there is just an economy of scale that happens eventually where we have to simplify things simply because we can't, this sounds awful and snobby, we can't rely on every person along that chain being even basically competent. I mean, not because PlayStation, it's not unique to PlayStation. GE, I used to work for, Penn State, huge, right? I mean, when I fire this down the line, I have no idea who's consuming it, right? So one of the reasons things like ARP down, ARP now, and all these stupid things come about is because they take a complex topic and they concatenate it into a simple knowable number, right? Like imagine it, but on some philosophical level, though, it's a bit bizarre, right? Like, imagine if you went to a marriage therapist and they said, I think your marriage is like about an 8. What does that mean, right? Like you're taking this complex milieu of things and down into a number. So I don't have a great answer for that. When I worked at a smaller company, at Volition, the answer was literally just sitting down with the CEO with beer and talking about exactly what was happening. That is not feasible in a 50,000 employee company. Sorry. More questions than answers. That's what I'm good at. Anybody? I don't bite much. Yeah. I'm pointing at you. What's up? I can use the laser pointer, but you probably don't want me to.
So when you're analyzing data from games, how experienced do you have to be with playing those games? Because I'm concerned, you know, like potholes or like bars where people can't play the game, but if you're experienced with it,
Yeah.
you know that certain area is like supposed to be designed that way.
Sure. That's tricky. So obviously, game studios hire people that like games most of the time. You'd be hard-pressed to find somebody in there who just hates video games. You know, it'd be like working for a hockey team or something. You hate hockey. It'd just be stupid. I mean, you'd just be a bad life choice for you. Mormon porn star, you know, it doesn't work. So anyway, everybody plays games in the office. We all do. CEO plays games. We're games people. So to some degree, I guess we don't necessarily run into that problem super often. But you know, not everybody plays every game. Like, I mean, ultimately, I'm working on a lot of like free-to-play, what they call incremental games. What I call like, no, never mind, that's way too offensive. So the games where you like cookie clicker, where you're literally doing nothing but just like having a fit and clicking on something, like sitting there. And so anyway, they're popular for some reason. And you know, I've been working on those, but I mean, me personally, I hate those fucking games. So I know how to play them, so I stomach it. There's somebody out there somewhere who like hates, I don't know, things that are good. So they work through it though. So sorry, again, I don't mean to be glib, but the answer is basically nobody knows everything about every game. There's too many of them, right? But we try to stay up to date. Yeah, go ahead.
So is there like a particular bias? Like if someone's played a certain amount of game, like this many hours, they're more likely to be put into like
Oh yeah, no, not at least not for us. I mean, so the teams are big enough at PlayStation that I think they kind of just people's tastes are. I'm turning people into numbers again. People's tastes are more or less randomly distributed, right? Like, I mean, they are, right? Like if I take a hoop, this is like biology 101. You know, you take a clothes hanger and you throw it in a hoop, and you throw it onto a lawn, and you kind of like sample the biodiversity that's in that area to get an idea of the whole lawn, right? So it's very much like that. Like if I took a clothes hanger, a really big one, and caught like 5 or 6 people in here, and I asked them about the kinds of games they play, the kind of food they like, you know, it's as likely to represent everyone in here, all things considered, as anyone else. So our teams are big enough that I think we kind of obviate that just by virtue of the fact that we're all kind of different. What's up? Yeah. Ah. Yeah. Yeah. Great question. Answer it and send me a resume. But again, that's goofy, but that's really the answer. We have a lot of procedurally generated games. No Man's Sky is not the first. It's just kind of one of the bigger examples. But there's tons of these, right? Like Spore would probably be the first popular, well-known one back in like the, 2007, 2006 era. Will Wright is a psychopath, by the way, if you ever meet him. Where was I going with that? Oh, so obviously the discrete combinations are made by, to give you very quick procedural generation 101, nothing's really truly made from nothing, right? Like they use simple mathematical algorithms. Like I taught a class at Penn State Comp Sci where I taught about this a little bit, like generative algorithms. So you know how like, do you know the Fibonacci sequence, right? Like very simple mathematical pattern. So that's kind of how we generate trees a lot of the time, right? Because that pattern follows a really precise, like thoughtful pattern. And that kind of is how most procedural content is generated. I am like wildly simplifying it for the sake of answering this question. But so we don't actually track everything is the answer. If we tracked everything in No Man's Sky, our systems would literally melt down. And the return on investment wouldn't be smart, right? Like we'd be storing terabytes of data to get like little insights. So one of the things about big business, different from academia, is you can't blow 50 grand or 80 grand or 100 grand or $1 million to be like, oh, hey, here's this little nugget of an insight. And that's not a stab at academia. I've taught for years and I love it. But there's restrictions on business that if you're going to spend 100 grand, the expectation is that you're going to generate 100 grand or more. So a lot of academic things, that's not the case, right? Like there's studies on like nose picking and things like that. So I mean, that's not going to generate anything really. So you take my point. The answer is we more or less plan the algorithms ahead of time, make robust sample data, and kind of work with that. And then we detect kind of discrete things after the fact. You can imagine, for example, that we would plan on the kinds of procedural generation we wanted to see ahead of time and then detect whether it happened or not in the wild. I hope that's kind of, all right. Someone on this side, anybody? What's up?
So for finding out geographical trends for different kind of games,
Yeah.
so would you like weight different games as different ways? So it's okay, say Mass Effect 4 and like say FIFA has like a lot more
Yeah.
people in like one particular
Yep.
area, and other places will have like different area. How would you cluster them based on those like
Sure.
particular games and figure out those trends?
Yeah, so we have a few different kind of, and you're right. So to the point there, if you didn't hear it, and for podcast people, I guess, question is like geographical distribution of games differs by the title, and how do we kind of account for that? So for those of you who don't know, soccer is not necessarily super popular in the United States. Surprise. But in the rest of the world, it's immensely popular, right? Like, you talk about like Brazil, one of our kind of growing areas. Soccer is like life, right? So our like titles that are really like soccer heavy, FIFA, things like that, are obviously kind of more popular in places or in ethnicities that come from these places that are kind of more exposed to soccer. So as a result, yeah, our geographic map is necessarily full of sort of, what's the word I'm looking for, corrupting variables, right? Because necessarily if we say, oh, PlayStation Network growth is up in Brazil, it's sort of like, well, but it coincided with FIFA's launch or whatever. And it's kind of like, all right, so we have to account for that. You're absolutely right. Go ahead.
Like a normal K-means won't really work on it, but then you would have to weight those K-means on different kind of weights, right? How would you approach that generally? Like cluster them based on geographic location, or would you cluster them based on like games?
Yeah, so the good answer to this is it really depends on who's asking and what I'm trying to answer, right? We have a network team, for example, that asks us questions all the time about one of the things I mentioned, which is like anticipating how many users are going to be on at a certain point and certain. So as you might imagine, our network architecture has hot points all around the world, right? So to them, it actually doesn't matter what the people are playing. They just want to know when and how many. So when answering that question, we straight ignore it because it actually, like at that point, it doesn't matter. In terms of market growth, yeah, so we might cluster by like sports games. We might cluster by like open world action games. Genre is a really convenient way to cluster. We can't necessarily get a lot of demographic information. There's no ethical way for us to tell whether you are a 28-year-old white single dad or like a 62-year-old black guy who's working in Costa Rica. Like, I can't tell. So we don't usually do like social economic, that kind of touchy stuff. We stay the hell away from it for legal reasons, honestly. But it would be really interesting to do that kind of demographic separation and get kind of those data too, I think, because one of the big debates that hops around in the games industry all the time is like, women don't play games, which is bullshit, by the way. But that comes up a lot, and I'd love to be able to just kind of secretly turn your PlayStation camera on and be like, I told you I was right about this, but I would get fired. Anyway, sorry if I dodged that question. There's parts of it I can't actually talk about too. Yeah, no, maybe somebody else. Yes. Ooh, wait, Professor? One more? Two more? One? Eeny, meeny, miny, you. Sorry. After, mind me. What's up?
In your grad school,
Well, I was in Canada, so I smoked a. No, oh, hey, that's legal in California now. So, no, I meant crack, by the way. Anyway, so I took education. I was really interested in how people form sort of learning strategies around pieces of technology. So I studied interfaces. I sort of studied the role of audio in cueing people to use different parts of an interface. So if you're like, how the fuck did that happen that you get into data science? Great question. But really, data science is new enough that the backgrounds of, if you ask 10 data scientists how they got to a place, it'd be completely different for everybody. But yeah, I studied human learning, specifically with technology. Before that, I studied instructional technology in my master's degree. And before that, I taught high school. Cool. Thanks.